All right, well, why don't we go ahead and get started then? Welcome to another community conversation hosted by your Autodesk community. My name is Chris, and I'll be your community host today. It's my pleasure to welcome back Richard and Jorge, who will once again be talking about everything related to Fusion 360 electronics, and I know they just love to talk about that.
Yeah, thank you, Chris.
So, for those of you who might be joining us for the first time, community conversations are virtual meetups featuring expert speakers from across the community. Sessions range from deep dives, tips and tricks, live demonstrations on products such as AutoCAD, Revit, Dynamo, Fusion 360, to roundtables on industry highlights, emerging trends and career stories, and even more. All experience levels from beginner to expert are always welcome in these. Very quickly, we always throw up our safe harbor statement at the beginning of these, just to let you know that if there are any forward-looking statements made during these sessions, these are not to be taken as promises or guarantees of any functionality coming in the near future or the far future. Always look at the software and the condition that it is in today before making any purchasing decisions. So we have everyone's line muted to reduce the background noise, but if you're comfortable doing so, we invite you to turn on your camera so we can see your enthusiastic smiling faces. This is a conversation. We would like to get as many people involved in the discussion as possible. So use the Zoom raise hand and our moderators will unmute you so that you can ask your question. Or you can also use the chat window at any time, and we're keeping an eye on that to make sure that we don't miss anybody's question. We are recording the session and it will be posted shortly after the session is completed, usually within 24 to 48 hours on the Community Conversations page. So with that, that's enough of me talking. We're going to do some quick introductions and then I'll turn it over to our experts. So my name is Chris Benner. I'm the Community Manager for Design and Manufacturing here at Autodesk. Been with Autodesk for just over 2 years. And I was a customer expert elite and Autodesk University speaker for many years prior to that. However, I come from the other side of design and manufacturing. I was an inventor user, so sorry about that, guys. Sean, do you want to introduce yourself real quickly? And then we'll hand it over to Richard and Jorge.
You bet. I'm Sean Hurley. I'm Autodesk Community Engagement Manager located in sunny Bend, Oregon.
Hey, Jorge, you're up.
Yep, my name is Jorge Garcia. I'm located in Miami, Florida. I am a technical specialist, community manager. Basically, if it's electronics, me and Richard will help. So we're here to answer questions, to show you functionality, and there's always plenty going on to keep us busy here at Autodesk and the Fusion 360 organization.
Yeah, thank you, Jorge. So yeah, my name is Richard. So I'm for a long time working in electronics with ECAD systems, mainly Eagle and now Fusion Electronics for a long time. And Chris, no worries. If you come from Inventor, you found your way to Fusion. That's okay. So
I am learning.
Don't worry about it. No problems. Okay, yeah, man.
Right.
So now we had a break. So we had 8 weeks now since our last
I believe so.
Session. And what should we talk about? I think we had a new release in July, which brought a lot of improvements in terms of stability, in productivity, some nice, small and nice, little nice improvements. Should we talk about this, or what do you think? Yep. Okay.
Well,
thumbs up. Okay. Cool.
All right. I'm going to hand it off to you guys, and I'll be back at the end with a little bit of closing information and some resources for everybody. So.
Okay. Cool.
Thank you, gentlemen.
Thank you very much. Okay. So, I have. I think I show you just a few slides just to show you before we talk about it what we would like to show you. So let me share my screen. Yes, share screen. Here it is. I share my desktop. You will see Fusion in a moment now, but I would like to present this before. So yeah, what's new in July? That's the question here. And as I said, we have some productivity enhancements. It's about configuration, general workflows, schematic, the push from 2D to 3D. That's something yeah, we had a lot of improvement in the recent releases, and a little bit about libraries. And of course, one topic is Eagle migration. We help you to bring your data from Eagle into Fusion Electronics. And it's just a few minutes. I don't want to talk too much in theory. We had a lot of stability enhancements in the July release. A lot of crashes are reported and have been fixed. And we have performance improvements. And the thing I would like to talk is about productivity. Keyboard shortcuts has been improved. We have arrow key support and all the stuff, assembly variants, paste pins, document attributes, all these topics. In most cases, they're not new, but it was hard. A lot of them, it was hard to find in Fusion Electronics, especially if it came from Eagle. You know, okay, I have the assembly variants. I can click here or whatever. I have an icon for it. In Fusion, you have to search for it. If you didn't find it, then you thought, okay, it's not supported, but actually it was, but nobody knows. And that's something we worked, the dev team worked very, yeah, how do you say, hard on it, and we exposed all the things that are hidden in Fusion Electronics. The same with the paste pin command with attributes. And one thing is pretty new. It's about libraries. The supply pin topic. That's something we changed this a little bit. I will talk about this in a minute, or Jorge, maybe you or me. I don't want to talk the whole time, of course. And we have for the 3D push. So that means if you come from the 2D to the 3D, there's some new options you have. And then let's look at Eagle migration, how to import libraries. That's not really new, but just want to mention it again. And how to bring in an Eagle project automatically. And that's what we want to talk about. I have, of course, some slides prepared. I don't know, I will just hop through them. The support of the arrow keys, for example, all settings in one place. That's just, yeah, more details on what I will show you or what we want to show you in a minute. In the schematic, we had a lot of improvements. The exposure of the assembly variants, for example. Now I have a place can click on. I see what's the variant I have selected. So that's all small improvements, but I think it makes life easier. I guess we called it quality of life release. So that we really tried to make it easier for you to work with Fusion. That doesn't mean it was hard to work before, but now it's much more convenient as it was before, of course. Yeah, okay. So actually, what else? Yeah, the preset stuff. So the push to 3D, that's something I will show you in a minute and talk about this. And that's the thing about supply pin value assignment. So I will, that's something we have improvement here. Of course, as you might know, we have supply pins that represent a power voltage in your schematic. And for each voltage you have to define, a device in the library. So if you have 3.3 volts, then you have to have a supply pin. If you have V3, the name is different, then you have an extra pin, have to have an extra supply pin. Now that's much easier. Now I could, let me call it a template, supply pin template. I bring it in, place it, and then I'll be asked, so what's the voltage you want to assign? And then I just enter the value. That's much more convenient to work with, of course. I think that's really a nice improvement we have here. Okay, what else? So no, it doesn't now. Yeah, Eagle migration. That's something I think that's really nice, because maybe you know, and yeah, see Fritjo here also, you know what I'm talking about. In Eagle, you have a project file, and which says, okay, in this folder, I have a schematic on board with the same name, and so these two belong together. And all the settings I can do, or definitions I do for the board editor and for the schematic, that's all stored in this Eagle project file. And in Fusion Electronics, it works a little bit different. We also have a kind of project file, that's what we call the electronics design. And you have to know that you have to create this electronics design file in the beginning, in the very beginning, and then you start with the schematic or with the board, or you assign or link to an existing schematic and an existing board. The difference is in Fusion, the files or schematic and board don't have to have in the same folder. They can be anywhere and they can have any name. We talked about this some time ago, but just if you don't know it and you bring in your Eagle files, what would you do? You would upload it and then you would open it. Of course, you could work, but you don't have an electronics design behind kind of project file, and you had to create this before you start editing. And now we make it easy. You upload the board files, and then, as you see here in the image on the top right, you have Fusion Electronics detects, okay, this schematic, for example, demo 2, schematic and board belong together, and I create the electronics design file for you automatically, and that's really nice. So you don't have to take care of this. It happens automatically, and everything is good. So that's a big improvement. I at least I see it as a big improvement, and it helps to get started with Fusion Electronics easily. Okay, that's basically about all the stuff here. And so, Jorge, what do you think? Should we show a few of the features? What do you like? Or what do you like most of them? For me, I guess
Pictures are always awesome.
Huh? I don't see him anymore, but doesn't matter. So, but what I like most is, oh no, yeah, here he's back, back again. So I lost. Yeah, what do you like most of these improvements?
My favorite is the import of the Eagle projects, actually. I think for Eagle users coming into Fusion, that's going to make life a lot clearer because it'll automatically just make the electronics design file for them and link it. Sorry, I had to drop back. Just dealing with some stuff here in the apartment.
Doesn't matter. No worries. Okay, so how would we? Let me. I think I can demonstrate it. So what I would do is if I start now, I would maybe have a new folder in, or here my data panel shows, for example, the RH electronics. That's the electronics projects. And there are some subfolders, and I would create a new subfolder and say, okay, that's now I want to bring in my electronics, my Eagle design. And therefore, okay, let me go here and say new Eagle folder. I would write Eagle 1. And it appears in the list of, you see, I have done this several times. I have Eagle old and Eagle 1 and all the stuff here. And now I double click it and I'm in my Eagle 1 folder. And then I just go here for upload and say select files. And now I have to choose something from my hard disk, from the network drive, wherever you have your projects located. Actually, I don't want to search too much, so I just go into my applications folder. There I have a number of Eagles installed, and let me just go into the examples here. There we have just been examples, Chem Design Blocks examples. Here we are. Euro circuits. No, I don't.
Those are design rules. You got to go to projects.
Projects here we have, and then we have, for example, the Beaglebone Blue. I have schematic and board. I could also select them both because I want to upload them both. And now I say upload, and then Fusion gives me this upload option where it says, okay, I create the electronics design for you automatically. And I say, okay. And yeah, it takes a little bit until it's uploaded. And then you will see here appear the entries. I have my electronics design file, I have the schematic, I have the board, and that's it. So that's really all you have to do. As soon as it is uploaded, I can just use it. So I can close this one here and do a double click onto the project here on the project file. Sorry, I'm still used to Eagle. It's a project file. Actually, it's an electronics design file.
Yep.
And now you see a preview. That's my schematic. That's my board. and just go into it and start and work with it. Go ahead, whatever you want to do. And it's really simple, nothing to do. Just upload it and it's there. No conversion, so everything runs in the background. And the nice thing is the original files are unchanged, so no worries. So you just can play around in Fusion, and if you decide, okay, that's the wrong file or whatever it is, delete it. The original data set is still there. Nothing changes for you on the hard disk in the Eagle environment. Yeah, that's it. Simple. Okay, well, and then what else? We talked about the design, while we are in the schematic. I have mentioned the assembly variants. Now, if I'm here in the design manager, you see I have my panels tabbed, so that's just switch from here to there. And now I have a place for my assembly variants. So of course there is nothing defined, there is no variant, but I could just click here this icon, and then you see that's the main assembly variants. That's all the components that are in this one. I just go here and click new to have version 1 or whatever it is, whatever the name would be, and then I can decide on the value of the component. Should it be changed or not, or maybe I don't need these LEDs in the variant and I can just deselect them, so that's not populated, and then, that's the place here to work with the variants. Now, very simple to find here in the design manager. That's also one of the things here. One thing is I want to talk about is shortcuts. It's not just schematic related, it's also of course available in the layout or in the library. And you all know shortcuts. Of course, commands in Fusion are assigned to keys. That's the normal thing. And in electronics, we can do a little bit more now. I could not just, let's go here into connect, for example, and you see net is, for example, assigned to the R key. Of course, I can change this. I could go here, click onto the 3 dots here, and say, okay, no, I missed it again. Change keyboard shortcut, and then of course I can change it. That's the usual way in Fusion. As I said, we can do more. Of course, we expose our new function to you, and we show you, hey, we have shortcuts now. What we support is we support all the electronics commands, not just one command. You could have a series of commands. You could assign, running a script or running a ULP. So if you're coming from Eagle, it's very handy and very flexible in Eagle to assign whole command sequences to a function key. And that's what we can do here as well. So you see, I've done some of them, display non-net pins or something like this. So I switch off all layers and display a few of them. And I assign this to Shift-Alt-D, for example. And of course, I can also assign a new one. What could we assign? I say new shortcut. Good question. Yeah, display is the easiest one. Okay, I just type it in, display none, and just let's show display none, and that's the first command. Or I could do it in one and say, I don't know, symbols. Just show me the symbols layer, for example. That's it. And then I click here, and now I just press some keys, Shift, Alt, and I don't know, D, for example. And then it says, okay, it conflicts because that's already assigned. So I have to use another combination, Shift, Alt, just let's take F. Okay. And now it appears here. And if I do it, say, okay, Shift, Alt, and F. No, I did the wrong one. Shift, Alt, and F. Nothing happens. Cool. I did something wrong. What is it?
Did you put a semicolon at the end of the there?
Yeah. Let me check. Oh no. Wrong, that's the wrong one. Shift. There is F. Yes, it did. Oh, yeah, I misspelled display. Okay.
There you go.
There we go. Yeah, so yeah, that's okay. So I delete it again and then let me just do it. New. Okay. Okay. You see, it works. I use now this one and say Shift Alt and D just shows me net and pin layers, and it starts the net command. So I have a combination of those. Okay, and if I use it, Shift Alt and D, now it changes the layers, you see, and then the net command is already active and I can start. And that's something, of course, you can have any combination of commands there. Really nice.
Yeah.
I like it.
Yeah, to add to this one, you can almost treat it like a macro. You know, in the
Yeah.
case of Fusion, the default shortcuts are single key, and it just starts the command. In the case of electronics, which is what we had in Eagle and we ported over, you could have the sequence of commands, but beyond just that, you could also pass arguments. So you could specify, for example, the net width before you start the net command or before you route. So you could automate a lot of tasks because you could do combinations for the shortcut. So if there was just a sequence of commands you were constantly doing, you could just have a shortcut and it would do that entire sequence, which is something Fusion on its own couldn't do. So we added this functionality, and hopefully others in Fusion can see the benefit of it. In order to not conflict with normal Fusion shortcuts, they're not single key. So normal Fusion shortcuts are all single key for the most part. In the case of these always involve a modifier. So you'll have Shift, Alt, Control, whatever, plus a letter. And in doing so, we don't conflict with the default Fusion shortcut system. So if you're working in electronics, you now have the best of both worlds. You have the more versatile, kind of original Eagle shortcut system, and you can still leverage the Fusion shortcut system when you want to do single key things. So it's kind of the best of both. Yeah,
you see it's here also in the layout editor. What we see here, we see always all commands. So I have also my keys that are assigned in the schematic editor or work in the schematic editor. I see it all in one. That's the only difference to Eagle. There we had the selection. If I'm in this schematic editor, if I remember correctly, I just see the shortcuts for schematic. If I'm in the board, I just see the shortcuts for the board. Here I see all of them in one list. So that's the only difference at the moment I think we have. But it's really nice and it's very, very flexible. Actually, you could build your whole schematic on the keystroke. You could write a script for it and say, okay, add components, connect the nets and do all the stuff. So if actually a long time ago, people sometimes did things like this. I remember we had some script files that created drawing frames for schematic and board, for example.
Yep.
That's something. That's not so unusual to do it this way. But
that's quite the artistic schematic, Richard.
This board is the BeagleBone. So this is kind of like one of those single board computers, kind of on the level of the Raspberry Pi type situation. And they designed that specific board in Eagle. So you have this board is I think six layers, might be more.
Wow. Let me check. I could check it for you. If I go into the display command, I see.
How many is it?
It's a 4-layer board.
It's a 4-layer board. Okay, so
4-layer, yeah.
And yeah, it looks dense, but it
looks really cool. I'm waiting for you guys to open one that's like in gradients or like, it flows from colors. We got a rainbow board.
Yes. Yeah, actually, what we have is the single color mode. So that's something, because if you're working here, now we have top. Now we have the top layer on top of your drawing. I could change this if I go here into the layer box and would say, okay, I select bottom, and you look at the screen now, you see bottom comes on top, so to say, so it's better readable. But there's one more thing, that's the single layer mode. I really like this one. So if you have a lot of layers and it's hard to distinguish, it distracts a lot now. If I'm working in the bottom layer and I have the yellow lines and the red lines, and so it's not so easy. It's also depending on the color scheme, but I could do something like this. Click here and say single layer mode. So now you see I have the blue one, the bottom layer is active at the moment. All other things are gray. If I switch my layer, that's also on the fly. If I'm routing and changing the layer from top to bottom, that's what I'm simulating here. I go here. Now I have the red one available. All the other things is gray. So that's less distracting. I think that's a really nice feature here.
Yeah, especially in dense layouts like we're seeing here. You know, then this one's only 4 layers, so you're essentially just dealing with 4 different colors that you have to visually distinguish. But if you have an 8 or a 10 layer board, it just becomes a giant spaghetti of traces. So, you know, having single layer mode makes it clear what layer you're on, so you can avoid crashing into things. Because when you have the whole jumble of colors, it's kind of hard to distinguish if you can actually route in a certain spot, because you can't tell, it's too many colors overlapping.
Yeah, that's true. Yeah, and what I did was, because you just see half the truth now, because I switched off or hide the polygon areas. So usually we have copper areas. So let me recalculate it in polygon and say refill polygon 4. No,
I think it's show all.
Yeah, it's show, yes. And then that's actually how it looks like in this layer, because we have the polygon. So that's usually a ground plane. So all the objects or vias and traces that are connected to ground are in one big plane, for example. And so that's usually very often done in inner layers. If I go to 15, here I have also a copper layer inside. And let's check bottom.
Yeah, usually bottom and top get the traces. So their polygons are not fully solid because you have all the traces cutting through them.
But that's also a polygon. So, and if you would switch on all the layers again, then it looks like this. And of course, it's hard to you then. Yeah, that's one of the really challenging things in electronics. It's not comparable to graphics in mechanics, for example, because here you have just lines. Okay, it's not true you don't have just lines, but that's something it's challenging to really look through this, of course.
Yeah, it's 2D centric. So electronics CAD doesn't really on its own. If you just look at pure electronics CAD, you're never dealing with 3D. It's 2D, it's 2.5D, I think is what we can call it. You have you're looking at it from the top, and you have X-ray vision looking through the board. So that's why you'll see that some of the text looks backwards, and that's because it's on the bottom. Any text that's on the bottom, if you had that X-ray vision, you were looking at it from the top, it would be backwards.
Yeah, that's true.
So it's like a 2.5D view, let's say. And that's how electronics has always worked. So having 3D is nice. But I would not want to try to lay out a board like this in 3 dimensions. That would not be fun.
True. Yeah. Especially if it comes to multi-layer on top maybe, or on bottom. Yeah, okay, that's doable. One layer that might be okay, but if you think you would have, as you said, 8 layers or maybe, and 8 layers is not so unusual. It's a smaller percentage, of course, but usually you have 2 and 4 layers. I think that's the main.
Majority
designs, yes. And 6 and 8 layers, but we support up to 16 layers in electronics, and that's something that's really getting complicated. So it's also.
I can only imagine what a cell phone schematic is like. I mean, there's got to be a lot going on there.
Oh yeah, for sure. That would be an example of like 6, 8, maybe more layers. Just because of the density, just how much you have to cram into.
It depends on the the components you have. So we have some components that are called BGA. I'm just searching for maybe I find.
You have one here, Richard. If you zoom out, it's that one on your left.
There's one in. So
this is a big one, but here
it is. Do you see it? No, you don't see it. Let me switch on single layer mode and bring. It's
It's gonna help a
So
little bit. It's all those little circles that you see in the middle. You see how you have like a rectangular array of little circles in the middle?
let me show you a little bit more, because so what I can of course also do, I could switch off some of these layers here so that you get a little bit more clearness here. And I switch on the top place layer. So there we
That-
have
Oh, wow.
That rectangle, a square.
the rectangle here. And now let me go to top again. Okay, no, that doesn't work. I did not switch it on. Yeah, it is.
I forget how many balls that one has. I think it's 256, but I could be no, it's more than 256.
I'm not sure at the moment. Okay.
You'd have to look at the info. But each one of those little pads is a connection point. So it's so densely packed, that's what allows it to fit on the board. So if you look at your phone, almost everything in there is this type of package because it's the densest available. It's also the hardest one to work with because soldering it is a pain, breaking out all the pins is a pain.
This is truly really fascinating. I'm a recovering mechanical designer and did piping.
Oh Lord.
Large. I mean, this looks like a piping battery, but complex. But we used to joke about running pipelines, whether or not we made them look aesthetically pleasing from a plan view or a drawing view. I wonder if schematics, is there a bit of, to an electronics designer, that they think about the things, the aesthetics of their board? Are they going to be critiqued and how they did this, the pins and all this?
That's actually a good point. So some do. So for example, in a board like this where you do have a lot of high speed, the physics trumps the aesthetics. So you have to make sure that the thing is physically going to work first.
And we talked about things being too close to each other where they get the RF and they joke.
So you have to make sure of that. But usually, actually, aesthetics things tend to conform to physics pretty well. It's rare to have something that is aesthetically pleasing, but physically is like a wreck.
Yeah.
So, go, Richard.
Yeah, just talking about sizes, what I wanted to show you is if I use the mark command here and set an origin here, just to get an idea what the sizes are. If you see now, I have relative coordinates from here, and this is what is it? It's what's the units? Okay, it's 1 inch about.
About an inch by an inch.
Yeah,
roughly.
So it's quite.
That's pretty
It's not too
small.
big. And we
It's
have
small, and you have I think it's either 512 or 1024 balls there, but I'm gonna say 512. So in an inch by an inch, you have to break out 512 connections.
Yeah, it's 20 by 20, so it's theoretically 400. They're not all covered.
Oh,
so
it's 20 by 20, so it's 400 then.
It's about 400
balls.
connections. 400 connections in a square inch. That's not so bad. And such components can have up to 1,000. I saw one with 1,500 connections.
Right.
And now you can imagine if we have if the number of pins increases, so we have a number of rows increases as well, and then you have to bring out your signals from these connections here, and therefore I need vias, so I go a layer deeper so that I have enough room to bring out 2 rows of connections. Then again I have to go 1 layer deeper the next rows, and depending on the number of rows you need
many number of layers.
Yeah, the more connections, the more layers, and the more complex all the stuff is.
Yeah, so like in this case, if you look at this one apparently didn't have to make that many connections, so they didn't follow kind of the typical algorithms that we do to break out something like this. But like Richard was saying, if you have one of those crazy dense ones, like 1,000, there is an actual algorithm. You can get on each layer, you can break out 2 rows moving towards the middle of the BGA.
Usually, yes. Yeah.
So you'll need, if you have, 20 rows, for example, and you can get 2, you'll need a 10-layer board to break them out.
Yeah.
So you start working your way towards the middle.
And so if you want to see the whole truth, then of course now we have in the inner layers, I don't know what's there. No, there are no connection. We have just mainly we have a ground polygon there in the inner layers. Oh, there are some traces in the inner layers, but and then it's crazy.
And this one is not so bad because this one is
No,
not that dense.
That's true. So not all of the connections are used, but sometimes it happens that you really have more or less use all of them. And then it's getting tricky, of course.
I would honestly, on some of these, I would actually print these out in an 11 by 17 and put it on a wall. And that, I know that sounds geeky, you know, or if I had a tech space or something, I would put some of these. They look fascinating.
Yeah, you're not alone. There's people that do that, that treat them
Actually,
as
Oh my
art.
God. I want to reach, I got friends that work at Intel. They probably wouldn't share any of theirs, I'm sure, but I can only imagine what their transistors and stuff. I have a friend that does micro welding, so.
Oh man, yeah.
If I remember correctly, I met on one of the Autodesk universities in Germany some years ago. I met an artist, and he does art with printed circuit boards. So he prints them and or whatever he does, but it's really, yeah, it can look. Sometimes you think, okay, this is something I would pin to my wall. That's really great in a big format. Seeing the printed circuit board, and he really had. I didn't see them live, but he showed me some pictures. That's very awesome. Cool.
I'm going to go to Etsy after this. I'm sorry to take us down this rabbit hole of art, but I mean, I've been dealing with engineering graphics for over 30 years, and I've seen a lot of drawings of different things and components and stuff, and I can appreciate when they're well thought out or they look, kind of artistic. These are unbelievably beautiful.
They are.
All right, I'll step back and go on Etsy and buy some.
Don, I used to have an engineering manager who would tell all the designers, first make it work, then make it mechanically cool.
Yeah.
Yeah, well, I mean, I've seen some sloppy stuff. I don't know. And I do, so I have seen a lot of makers. I've been in a lot of maker spaces where they've done boards and stuff, and I see some of the quick, I've seen some stuff, and it would be like how I would do it, I would think, at my skill levels in electronics design. But this is a whole new level. This is somebody's a professional. This is very complex.
Yeah, we know the guy personally that did it, and yeah, he is very capable. And it's interesting because you can tell usually when someone is new at PCB because they'll start going off in all sorts of weird angles. If you notice here, everything is either a 90 or a 45.
Yeah, that's really that's the professional here. Yeah, that's
I do know that people will route in one area to do something that marks them. It's though I've heard of this. Like
there are people who try to put a signature in with a certain detail or a certain thing that they always do with their boards.
The micro welders can put in like one atom little things for their names, and so actually the QA people go looking for that kind of stuff. Everybody wants to be on that one microchip.
Right, that nobody is ever going to see that because it's a microscopic level, but it's there.
Yeah, that's true. Yeah,
it's there. That's the important.
Yeah, but you see, it's all properly aligned here. So that's
Sometimes we'll get users and you just see them in all sorts of funky angles, and it's not that it isn't manufacturable, but generally it's not considered good practice because if you have like an acute angle, that little corner there will accumulate extra acid and it'll etch deeper. So it'll actually, you have a chance if the trace is thin of damaging it. We call them acid traps. So always routing 90s and 45s avoids that. And those are things that come with doing the work and seeing how other people do it. And nowadays manufacturing processes are so good that even the acid trap thing, unless you're going really, really tiny, isn't that big a deal. So a lot of users get away with it. So they just keep drawing boards like that for years. But when you look at something like this, you see how it should be,
Yeah, this is amazing. I would love to have a printout of this one just for the wall. And by the way, I just did look at Etsy. It's a whole genre.
Oh yeah, for sure.
There is crazy, beautiful motherboard wall art, semiconductors.
Yep.
Wow.
Yeah. It is very much an active community. And sometimes you'll see people who will get a motherboard and they'll just get all the pieces off of it. And they'll use that as a basis for art, get like old computers and stuff and just make a solder pot, just get all the parts off.
Right.
Little dangerous. You got to know what you're doing, but so not recommending anybody to do that. But the results are often quite nice.
You shouldn't do if you plan to use your device anymore. So
Yeah,
yeah, but
that's-
yeah, it's
but that-
really really nice. Yeah,
Yeah.
it's really art. Can be art.
And Sean, you can print this out if you have Fusion installed. This is one of the oh, it's not one of the demos, but we can make it a demo. We can upload it and
That would be awesome. Yeah, this is beautiful.
Yeah.
I actually may write a public blog post on this. This really got my brain chunking along. I love this.
yeah.
That's great. Cool. Yeah.
Besides the functionality, but I mean that's even more
Yeah,
impressive.
sure. Yeah.
I just could look at the surface level. So sorry.
No, it's good.
No, that's good. Yeah. Okay. So yes. One thing. What else? Just yeah. That's really a totally new aspect of looking at the board. Not the technical stuff, but it's more the how does it look like. And yeah. But I think it's always a combination. You if you have a professional layout or board designer, whatever it is, it's like handwriting a letter. You know, some people know, okay, this board is done by this guy. I know him because that's exactly, you recognize it how it is done. There are people that they're really professionals, and
likewise we can recognize usually by looking at a board if it was auto routed or not.
Yeah, that's true. Yeah,
because auto routers don't do stuff like this. You'll see lots of crisscrosses and lots of weird transitions where maybe you wouldn't expect them to be. So at this point, we've looked at so many that I know Richard and I at a glance can look at a board and say, okay, that was auto routed. That was done by a person. That was.
Yeah, true. This one was definitely not, I guess.
No, that one was not auto routed.
It's not auto routed. It's manually routed, or maybe, yeah, actually the Fusion routing tools, they're really good. So you could route a bunch of signals, and then you see something like this here. I don't know if you see my mouse cursor in this area. Let's see. Okay, I know that's the wrong command.
So yeah, we can do the parallel routes, and it'll kind
the parallel
of
routes here. Yeah, for sure. Yeah, but actually, yeah, but it's it's.
But
nice.
when this board was made, that didn't exist. So I know this person did it by.
Yeah, that's true. Long time ago. Yeah. Okay. Well. So one thing maybe which I had a bunch of new features I wanted to look into the preferences. So if we go here into go into preferences, we have everything, all the
default
settings in one place now. So we have the electronics section here, and that's what you already know. This general settings I have all about colors, and now we have defaults. Okay, drills and miscellaneous and grid stuff, and now the defaults. So you can decide what is the default value if I start a command. If it's here the route or the line command for traces, okay, default is 6 mil usually. Or for vias, what is the diameter? These are millimeter-based values. That's the reason why we see it here in mil at the moment, because the grid is set to mils here, so that's could simply switch it. Of course, you can add all your own values, and that's something you did or had to do in Eagle and the Eagle script file. And now we no longer have to edit script files. You do it directly here in this dialog. I think that's really nice. And as there was a bit of a discussion about adding a few more of them, I don't remember what it was, but yeah, it's the first step. But everything in one place, so you can have all your settings done here in this preferences, electronics preference dialog. Okay, that's it. The last thing I want to mention, and I think that's important because that's something, it's about supply pins. And I hope I find it's what I'm searching for. So
yeah,
there is
you may want to open a simpler design to show that off, Richard, because this one's pretty dense.
Yeah. I could just create, oh, I closed this one. Yeah, let me save it. So I have something. Usually I would add a command here, but okay. So let me go ahead and do a new electronics design and start with a new schematic.
Or if you, well, what I meant is you could use a simpler example because the BeagleBone is big.
Okay,
so
okay. Yeah, that's, oh yeah, sure.
you
Okay.
could grab like the one-dimensional Pong or something like that. That's
Good
easy.
idea. Let me go back to yes and no. Let me go back here. I have something very simple, I guess. But I have a lot of test files usually. There is nothing in it. So that's okay. That's, yeah, here we are. Oh, this says example 1.
There we go.
That's nice schematic look. That's what, yeah, I did some simulation stuff recently. And well, yes, I could, there you see ground symbols, for example. So that's a supply symbol. And usually we have a library which is supply 1 or supply 2 with Fusion. That's coming from Eagle. And with Fusion, we have power symbols library now. And I hope that's, let me check if I have it in use. I go into the place components panel and it's, no.
You can type it in it,
Symbols.
Richard. You can type it in it. You
Yeah,
can
there
you
it
can
is.
type it in, it'll filter down.
Yeah, that's true. I have power symbols.
So just a little bit of background for those that are not EEs. Basically, in this example, it's pretty, it's not necessary, but you can imagine in the BeagleBone example, what ends up happening is electricity always flows in a loop. So in this design, what you would normally do is you would have, instead of the ground symbols, you would just have a closed loop, right? Battery through resistor back into the LED. Okay,
Right.
to avoid drawing that explicit connection, you can put in the symbols. So everywhere that there's ground is connected to every other ground, is basically how that works. So in doing so, you can take a really complicated schematic and you can avoid having to just explicitly draw all these loops flying all over the place, and it becomes very cluttered. So you can imagine, what we were looking at before, thousands of loops, thousands of traces that are crossing multiple sheets to come back, it becomes impossible to track. So by using a supply symbol where you know that every instance is automatically connected to every other, it mentally is an easier thing to keep track of.
Yeah.
And that's why we do that.
So what I've done now while you were talking, I changed the power symbols libraries because this was an old one or whatever it was. So I'm not really working with Fusion Electronics, so I'm messing around and have a lot of things. But that's the power symbols library we have now. Just let me maybe delete these symbols before I add a new one, and I hope this is the correct library now, but I think it is. So if I would like to connect this, I would take, let's say, a ground symbol. Is it the correct one? You see here the preview. And I do a double click onto it. And then I just connect it. I just place it on the net. And now I will be asked, what's the signal you want to use? And it should be connected. The suggestion is GND here. I could change it and say, okay, it should be 0 volt, for example, or something like this, because depending on the naming. So here is the place to say, okay, it's 0 volt. And then say, okay. Now the original name is N$1. The net got an automatically named. And now I say, okay, yeah, it should be 0 volts. And that's it. And I could do the same here, place it. Now it's 0 volts is already here and it says, okay, do you want to have it? And then that's it. So now I can decide on the voltage while I'm placing it. That's much more convenient than going into open the library, create a new symbol, create add a pin which has to have direction supply, make the device, save the library, go back in the schematic, add the newly created supply pin and bring it in. So that's much easier now. I'm asked what's the voltage and that's it. So much more convenient as it was before.
So basically, just to recap, the old way, they were all hard-coded.
Yes.
So then the voltages that they would define were all hard coded. You couldn't change it. Now it's more flexible. We can use it as a template. We can assign it to be whatever name we want it to be. So that's the big change. And this is what most ECAD users expect. Most of the other tools in our space kind of treat them as a template, and the user assigns what net they want it to connect to. And now we can do that as well.
Yeah, and you see we have a number of symbols, of course, predefined. But if it comes to new voltage, take one and assign, change the value of the supply symbol, and that's it. So if I go here, I could simply change the value. I guess that's possible. If 0 volts, 0 volts, and now I say, okay, it should be GND. Also, okay, and then I'm asked, okay, do you want to add, all segments? Of course, yes. Everything should be changed, and then now I switched it to GND. So it's very easy to work in this. You don't have to delete the supply pins, bring new pins in. So much easier as it was before. I really like it. We still, of course, support the old way of doing. That's not a problem if you're used to do. Then continue, or I think there will be a tendency to use the new way of working because it's just easier as before.
It is.
Okay. Yeah. So we have a few minutes left. Should we mention something, Chris? What do you think, or should we start the ending sequence?
That's totally up to you, gentlemen.
If you want, Richard, you can show the arrow key move. Just
Okay, the arrow key move. Yeah, of course. So what I can do is, of course, move command, zoom in. Click onto maybe the R1 here. Now it's selected. And now I have my keyboard here. No, do you see it? Yes, you see
it. Barely we can see it, but it's there.
No, it's
being hidden by the background.
Here it is.
Okay, now I see keys.
You see, it goes down. Arrow up. Oh, yes, it goes up. So I can really work with the keyboard. That's really nice. In the schematic, I think it's not.
It's not as useful, yeah.
No, but if you go into the board, of course, what we have seen before, and it's really critical, and to have to use maximum use of space, then it makes sense to just use the arrow keys. And now you
can nudge
in the current grid units, you can jump and align it and check one more. And with the mouse, sometimes it's much easier to use arrow keys. It's a defined step, one grid unit to the other one, grid. With the mouse, you have 10 or 5 or whatever it is, and so much easier. Yeah, actually, that's something I heard when I started nearly 30 years before with Eagle, and in the very, very beginning was one of the requests: do you support the arrow keys? Or other way, why don't you support arrow keys?
Well, now you do.
Now we do. Yeah, but that's nothing we, of course, that's easy to do, but there have been a lot of preferences doing all the other stuff before, and since all of this happened a lot, but meanwhile we have it. So yeah, it's really cool to have. But of course I can also use my mouse,
okay.
Yeah,
nice.
Yeah, I think it's really nice. So you could really jump in. You could even change the grid and say, okay, I changed the grid to 5 millimeters, and they do one mouse click, one arrow key, and it jumps 5 millimeters. That's really nice. A defined jump would be possible to do. Okay. Well, yeah, a lot of more things we could mention. Let's talk about this next time, I guess.
Sounds good.
Sounds good. All right. You want to give me the screen back then?
Gotta give him back the screen, Richard.
Gotta give me back my screen.
Sorry,
He doesn't want to give it up.
He doesn't.
Okay, yeah, okay, you can have your screen. Okay, sorry.
No problem. No problem. All right. Well, speaking of talking about things next time, you should be seeing our upcoming sessions for these for this Fusion Electronics series. Our next one will be in September 14th at 10 a.m. Pacific time, and then again in October on the 26th at 8 a.m. Pacific. So please go to the Community Conversations site and find these and sign up for them so you don't miss out on all the fun. Because this was a fun session. Now,
Yeah,
here, I
so-
mean, we're talking about framing PCBs for artwork. So, I mean,
Hey,
Yes.
it's been done. It's been done, man.
it's been done.
It's been done.
I try to find one of the images from the guy I met a long time ago. Maybe I have one.
Yeah, you can share it next time.
Yeah, I
So,
try to.
thank you, everyone. Thank you, Richard. Thank you, Jorge. Thank you, Sean. Thank you, Frijo.
Thank you.
If you're interested in becoming a community conversation speaker, we'd like to hear from you. This convenient little QR code here on the page, just take a picture of that and it will take you right to our session proposal form to help you get started on your journey.
Cool.
We also would like to see you all throughout our community. Make sure to join us in the forums, of course. Check out our community groups. Look at our Community Voices blog and read what people have been posting up there, and then maybe even consider joining as an author on that. Also follow our Community Journal blog, which is news from us for you. Things like upcoming events and member spotlights and announcements, things like that. Join the Student Group Hub or share it with a student that you know. And of course, keep up on all of the latest community conversations. I would bookmark that site because you never know what you're going to find. And there's always something good coming up. With that, thank you all for coming, and we will see you next month.
See you, everybody. Have a great rest of your day.
Thank you. Bye-bye.
Bye.